So let's look at the value of a derivative at a point using first principles. They've given us an example. If fx is equal to 3x squared, find the derivative of fx, well, x, if x is equal to 2 using first principle. Now there are two methods to do this. No matter which method you choose, whenever you're using first principle, you have to define two things. You always have to define fx and fx plus h. And once you've simplified these items, our substitution becomes a hell of a lot easier. So here we end up having fx is equal to 3x squared. Not a difficult thing. They gave it to us. But now what am I doing? Well, wherever there is an x, I'm replacing it with an x plus h. So I'm going to go 3x plus h squared. Okay? And how do we simplify that, guys? Well, we end up doing the perfect square. So much easier if you simplify it up here. Don't make a mistake, okay? So you always do the perfect square. So you keep the 3 outside and you end up going square the first, times the stuff inside, and double it, and square the last. Times the 3 throughout, you end up getting 3x squared plus 2xh plus h squared. So we've simplified that. Now I'm going to show you the two methods. This is method 1 using that whole system. And then we'll do method 2. We'll redo all of this for method 2. Okay. Method 1, you end up writing the derivative rule by first principle, which is the limit as h tends towards 0, we end up having fx plus h minus fx all over h. And the object is always to try and maybe get rid of this h, okay, because we don't want it to be 0, otherwise this becomes undefined. Now, we keep the limit until we get rid of that h. So h tends towards 0, you end up having fx plus h. Now, what is fx plus h? Well, we calculated it to be 3x squared plus 2x. Oh, no, careful. I obviously did not multiply my 3 in here. I hope you guys were shouting at me and saying, ma'am, multiply the 3 in. Okay, so we end up having 6x plus h plus 3h squared. There we go. So 6x times h plus 3h squared minus 3x squared all over what you end up having, h. And we can simplify. You can clearly see that 3x squared minus 3x squared cancels each other. And we're left with 6xh plus 3h squared. Now, if I take out a common factor here, I see that h is my common factor. So let's go take h out as a common factor. And we end up having the limit where h tends towards 0 is h is taken out as a common factor, and we're left with 6x plus 3h all over h. And now what we can do is we can now simplify this. We can cross cancel that out, and we end up having h dividing into h, and we end up having the limit where h tends towards 0 gives you 6x plus 3h. Now that we've eliminated our denominator, we can now substitute 0 in, and we know if we substitute 0 in for the h, you end up just being left with 6x. If you know your rules, it's easy enough to figure this out. You can check back and say, yes, it's definitely 6x. When you learned your rules, come back and watch these videos again and then see how it was that I could say, yes, definitely the answer is 6x, that I could have checked myself. And that's the nice thing about these questions. They are worth 7 marks sometimes in your test, an enormous amount of marks, or 5 marks, and you can check that you got your answer right. Whatever happens here has to be factual, and we need to be able to follow on the path that you got this correct, but we can then see here that it's right. I'm not going to give you all full marks if this is right and none of this makes sense and this is hogwash. That's what's happened a lot in the past. So make sure that you know what you're doing here. This is just a formula. Substitute your items into that formula, simplify it down into its simplest form, and then substitute that 0 in to eliminate that 3h to get your 6x. Okay, so that was method 1. I'm going to show you method 2. Guys, if you have, let me just write a little note here so that you can put a little note in your, if you have more than 1 point, do not use method 2. If you have 1 point, use method 2, but this is for if you have more than 1 point. Why do I say that? Remember, when we go back to that graph that I was telling you about, this graph is a parabola, right? We could draw it here. And if I had to draw this graph in, let me just quickly draw it in here. It's a happy face. It ends up being like that. Sorry, that ended up going funny there. It's a happy face. This graph's gradient, wherever it is, doesn't matter where it is, whether it's there, whether it's over here, whether it's over here, is now represented by this, by your 6x. So if I want to know what it is going to be, what is my gradient going to be? Oh, I'm using the wrong type of tool here. Hold on. I want to know what my gradient is going to be when I've got -2. I can now substitute that -2 in, and we end up getting 6 times -2 is equal to -12. And there, I've got my gradient at that point. If I had to substitute my x value here, that is possibly 3 in, I'm going to substitute that in, and I'm going to get 18. So there I can see that my gradient is 18. Is this a negative? Yes, it is a negative. Is this a positive gradient? Yes, it is a positive gradient. That is why we're doing this. This formula represents any point on this curve, the possible gradient that could exist, and we'll know what it is if we substitute those x values in. Okay, this is why we do calculus. This makes our lives so much easier when you go into varsity and you're trying to find out the rate of change in something. Sorry, I got halfway through my erasing and I realized that we actually didn't answer the question. We didn't finalize the question. We wanted to know the derivative of that, and we found that it was 6x, but we want to know what it is if the derivative of x is at the point 2. So I'm going to substitute my 2 in, which ends up giving me my 12. And that helps understand what that graph all meant. Okay, so take that down. That's the last part of that question. We're going to now go do method 2. So the same as method 1, guys. All you're going to do is now define it according to the values that they want us to find out. So they want us to find out when x is 2, what would my equation be? Well, fx is equal to 3x squared. Therefore, now I'm going to replace x with a 2. So we're going to go 3 times 2 squared, which ends up giving me 2 squared is 4. 4 times 3 is 12. And then we're going to go f2 plus h. This was normally x plus h, but wherever there's an x, we're replacing it with a 2. So we change this equation now to 3 open bracket 2 plus h squared. Wherever there's a variable in this equation, I need to replace it with what is in that bracket. So let's go keep the 3 on the outside. Those are not like terms. It's a perfect square. Square the first, times the stuff inside and double it. So 2 times h is 2h. Double it is plus 4h, because there's a plus there. And then h squared plus h squared. Now, don't let me make the same mistake again. I've got to distribute that 3. 3 times 4 is 12 plus 12h plus 3h squared. Now we apply the first principle law when we end up having x is equal to 2. So we write the limit when h tends towards 0 is equal to f2 plus h minus f2, or the function of 2. And we go all over h. There should not be an equal sign between these, sorry. So let's substitute the items in. We end up substituting that item in. First we write limit, h tends towards 0, and we're going to go 12 plus 12h plus 3h squared minus 12 all over h. Simplify the top just like we did the last time. 12 minus 12 cancels, and we can take out a highest common factor. I generally want to take a highest common factor of h out because I want to have my h's cancel. Okay, so, oh, wrong color. We've got our limit 12h plus 3h squared. Sorry, let's go take out that h first. We end up having 12 plus 3h all over h, and my h tends towards 0, which is equal to limit h tends towards 0. My h's can now cancel, and I'm going to substitute my 0 into that h, which means I'm left with 12 as an answer. And let me go back one step. We end up having 12 plus 3h. Now when I substitute that h in, my limit drops away and I'm left with an answer of 12. So we got the same answer that we got in method 1. Remember, this is now method 2. We got the same answer that we got in method 1, but do you see how restrictive this is? I have now only used point 2 to determine what that is. If I had to go further and say, okay, now find the derivative at point when x is equal to 4, you then have to redo this whole process again, and then you'll get a different answer. Whereas in method 1, if you calculated the formula, you would then just substitute that 4 in, which makes it a lot easier if you've got multiple points. Okay, but you do have to know how to do both, and make sure that whatever you're doing, remember, don't do what I did in method 1 where I forgot to actually substitute the 2 in. So keep that in mind. I hope that made sense. Remember, this is just a standard formula that you've got to use, and the derivative at that point is equal to 12. So we can see it's a positive gradient. The rate of change means it's changing, whatever's happening, it's changing by 12. For every 1 unit it's going across, it's changing by 12 units. Okay,